So this video is for the last two problems in E2, Part 2, numbers 10 and 11. So we have ourselves a photoelectric effect setup. So yeah, thanks to QBank, this question is kind of like mixed up. So number 10 says, monochromatic light of very low intensity is incidence on a metal surface. Light causes the emission of electrons almost instantaneously. Explain how this observation, and we will get back to that. All right, there is a question for that. Then it says, in an experiment to demonstrate photoelectric effect, light of wavelength 480 nanometers is incident on a metal surface, and the setup is shown. Graph shows variation of current with the potential of the cathode. And again, we have one of these voltage versus current graphs. So I just want to comment on this graph a little bit. So where the voltage is 0, there's still a current of, it seems like maybe 2.2 nanoamps, because even if there's no electric field applied to this setup over here, no electric field from the battery, there's still going to be a current because the photoelectrons are emitted from the illuminated plate across to the collector, whether there's an E field there or not. Okay, the other thing I want to point out is the stopping voltage, and it looks like the stopping voltage pretty much comes in at negative 1.5 volts. So just as at 0 volts, some photoelectrons go from the illuminated plate to the collecting plate, once a negative voltage starts being applied, that repelling field pushes against the photoelectrons. So fewer photoelectrons reach the collecting plate. That's why the current is going down from when voltage is 0 to when voltage is negative 1.5. But negative 1.5 is just at the point where there's just enough electric field to completely prevent any electron, even the most energetic electron, from reaching the collecting plate. So that's the stopping voltage. Okay, so AI says, does not support the wave nature of light. That's not a question. But wait a second, that actually comes from all the way up here. So, it says monochromatic light of very low intensity is incident on a metal surface. The light causes the emission of electrons almost instantaneously. Explain how this observation does not support the wave nature of light. Okay, great. That is a question. And the mark scheme pretty much lays it out for us. It says, with the wave nature of light, the energy would be transferred to the electron slowly, and so time would be required in order for the electron to be emitted. And it says that the electrons are emitted instantaneously. So there's no time buildup, so it does not support the wave nature of light. But in fact, the photon nature of light is supported, because it says in the photon theory, the electron interacts with a single photon, and that happens immediately. So there's an electron to photon pair, and that photon smacks into the electron and boom, transfers all of the energy at once, and then that electron can then leave the metal immediately. So yeah, the fact that the energy is transmitted immediately and the electrons can leave instantaneously means that that's a support of the photon nature, the particle nature of light. All right, BI says, what is the work function in electron volts of the metal surface? So we know that. Now it says, where the heck is the kinetic energy of 1.5 EVs coming from? Let's not forget that the kinetic energy is QV, Q being the electrical charge, elementary charge of an electron, and then V being the V stop, which is 1.5 volts. We saw that earlier on the graph. And so that winds up being QV, or rather VQ, or 1.5 EV for 1.5 electron volts. So that's where that is coming from. And then this guy right here, when it says solve for the work function would be HC over lambda minus that QV minus that 1.5 electron volts. So the HC over lambda, the lambda you can see is given right here, 480 times 10 to the negative 9 meters. But what the heck is 1.24 times 10 to the negative 6? That's H times C, but also H is in joules, and we're working with electron volts, so we have to do a joule to electron volt conversion by dividing by 1.6 times 10 to the negative 19. So if we do 6.63 times 10 to the negative 34 times 3 times 10 to the 8 divided by 1.6 times 10 to the negative 19, we get 1.24 times 10 to the negative 6. So that divided by the wavelength minus the 1.5 EVs gets us 1.1 EVs. And that is the work function of the metal surface. So then B says the intensity of the light is reduced by half without changing the wavelength. So we have a lower intensity. Draw on the graph the variation of the current with potential after this change. Well, we know that the intensity does not affect the kinetic energy of the electrons, so there's going to be no change in QV stop. So the V stop is going to be the same. But intensity does affect the current. If we lower the intensity is power over area, there will be fewer photons striking the illuminated plate, meaning there'll be fewer electrons emitted of whatever energy, because we didn't change the actual wavelength, so the energy is the same. There'll just be fewer of them, and so the current is going to decrease because there are fewer electrons. So basically, what would the graph look like if we had the same V stop, so that V stop is the same, but there was less current. So it's going to be a similar curve, but lower than the original with the same horizontal intercept because it's going to be the same V stop. All right, so that was number 10. Number 11 is the last question. It starts here and it breaks down to there. So let's take a look at 11. So for 11, we have more scattering of neutrons this time. But neutrons will also have a de Broglie wavelength. It's given 1.6 times 10 to the negative 15 meters. So when neutrons interact with carbon, they scatter around the carbon atoms and diffract, causing a diffraction pattern. And so that's what's shown in the graph of intensity versus angle. The fact that there's a dip at 17 degrees is a diffraction minimum where destructive interference is occurring. That would not happen if diffraction didn't happen, so it's evidence that the neutrons have wave properties. They also bring up the mass and decay constant of copper. We haven't talked about decay constant yet because that's an E3 topic. What is de Broglie's hypothesis? Not consistent with Bohr's conclusion that the electrons orbit in the hydrogen atom has a well-defined radius. And so de Broglie's hypothesis says that the electron is a wave, but if it's a wave, it's like kind of spread out and not localized. It doesn't have a definite position. So there's a probability density as to where it would probably be, but you can't really pin it down because it's a wave. It can't be pinned down. It does not have a well-defined radius. So then BI says, estimate using the graph. The radius of the carbon-12 nucleus. So the wavelength was given. That's the 1.6 times 10 to the negative 15 meters. So yeah, the 1.6 times 10 to the negative 15, that is the de Broglie wavelength. And then the 17 degrees, that comes from the graph. We saw that on the graph over here, 17 degrees. And we're looking for, it's like sine of theta is lambda over b, which is the diffraction equation, b or d, depending on the diameter of the atom, the size of the object you're diffracting through or around. And so they were solving for that d, as I have here. D is lambda over sine theta, and we get 5.47 times 10 to the negative 15 meters. Now it wants the radius of the nucleus, so we have to cut that in half. We're just kind of dumb why they just can't ask for the diameter, but we cut that diameter in half, and we get 2.8 times 10 to the negative 15 meters. Then BII says the ratio volume of a nucleus of mass number A divided by the volume of a single nucleon is approximately A. So in other words, the volume of nucleus of mass number A is A times the volume of a nucleon. So that basically, what that means, so the volume of the nucleus is just the number of nucleons times the volume of a nucleon. That means that there's very little space in between the nucleons. So, okay, But then what does that have to do with the strong nuclear force? And that's interesting here. It says because the nuclear force is stronger than the electrostatic force. That nuclear force is so strong, it packs those nuclei in, both the neutrons and the protons, so tightly together that there's really no empty space between them. So that's the second point. And then the rest of this for Ci and Cii deals with that decay constant they mentioned before, which is E3, not in this topic. So that is 11 and 12, and that's it for the E2 questions. Thank you.